This is part 2 of the video on sequences, and in this video we will be covering some special cases of how to find the sum of a sequence. The first special case we're going to look at is a series where it's like 1 plus 2 plus 3 plus, and then we can use ... to signify that there's numbers in between, and then all the way up to any number n. So basically this is the sum of all the positive integers from 1 to n. And to solve this, our trick of finding the middle number and multiplying by the number of terms will work. However, sometimes with a series like this, it's kind of difficult to conceptualize the middle number. It's sometimes hard to tell how many terms there are or what exactly you should use as the middle number, if there are two middle numbers and you need to average them, and things like that. So what we can actually do is kind of apply the basic trick we learned, which is the middle number times the number of numbers, to come up with a formula for the sum of this kind of sequence. And that formula is actually just going to be n times n plus 1 divided by 2. And you can see that this is actually pretty much the same trick because n is the number of terms, right? Because if we have a sequence from 1 to n, there's n terms. And then n plus 1 divided by 2 is going to be the middle term. So essentially it is the same trick. We're just applying it to get this formula that's easier to remember and apply. So for example, we can actually use this formula and see it in action. So let's look at the series 1 plus 2 plus 3 plus, and then all the way up to 100. So again, we can see that this sequence here is of this form, right? Because we're summing the positive integers from 1 to a number, n. And in this case, n equals 100. So it's important to identify what is the n value, or what actually is n in this case. And so once we figure out what n is, we can just use the formula. So it's going to be 100, so that's n, times 100 plus 1 divided by 2. So that's going to be 100 times 101 divided by 2. And what I like to do is first divide the even number by 2 so that we can kind of reduce the size of the numbers we're dealing with. So 100 divided by 2 is going to be 50. So now we can just do 50 times 101. And that's pretty simple. You'll get 5,050. And so that's an example of how to apply the general trick to this kind of special case. And again, you'll see it's not very difficult. If you think about it, it really is the same thing. It's just we've kind of condensed it down to a neat formula because, again, this is a special case. And so if we remember this formula, we can maybe do it even faster, and that's the goal. So that's one application of the basic trick. However, there is another kind of special case, which we will now go over. This second special case is adding the odd numbers from 1 to n. So that'll look like 1 plus 3 plus 5 plus 7 plus, and then like just keep going. You know, it could be till 9, it could be till 101, it could be to any odd number. So for example, in this case, well, for now, let's just write n. So this is the general case. Again, this is another special case. It's pretty similar to the last special case, except in this case, instead of adding all the positive integers from 1 to n, we're only adding the odd numbers. So if you see a series like this, you'll know it's this special case. And then we can use another trick to find the sum. And so specifically, to find the sum of this kind of series, what we need to do is first figure out what is the n value. And once we have the n, or once we've identified what is n, then what we need to do is add 1 to n. and then divide that by 2, and then square that number, and that'll be the sum. So it sounds and looks a lot more complicated than it really is. It's actually not very difficult, especially if you know your square numbers, then it's really simple. But even if you don't, it's really not too complicated. So let's just take a look at an example. I think it'll become a lot easier then. So let's look at the example 1 plus 3 plus 5 plus ... and then all the way up to 29. So we can see that this is of the same format as above. We see all the odd numbers from 1 to a number, which is n. So in this case, n is 29. And now that we found what n is, we can just use the formula from above. So 29 plus 1 divided by 2 squared. And so 29 plus 1 is 30, divided by 2 is 15, and then square all of that. So the nice thing about this trick is that you'll always get a whole number in the parentheses because n is odd, so when you add 1, it'll become even. So it'll divide evenly by 2, so that makes it a lot easier. And from there, right, in this case we have 15, we just need to know 15 squared, or kind of be able to calculate it pretty quickly if we don't have it memorized. I would recommend that you have your square numbers memorized from 1 to 20. It really makes number sense a lot easier, and it shows up in a lot of problems, like for example in a problem like this, right? So we can finish out this problem and we'll get 15 times 15, and so that's going to equal 225. Again, if you have this memorized, it's a lot easier. Otherwise, you can use any trick for multiplying two-digit numbers. But anyways, the answer would be 225. So that's pretty much it on sequences and how to find their sum. These problems can look intimidating, but they're really not too bad once you understand the basic trick and understand the formulas. And so yeah, that's it for this video. Thanks for watching. Please check out the description to see other number sense related content. We have videos and slideshows. And also, if you could, please fill out the post-lesson survey just to provide some feedback to us. And there's also a practice quiz in the description if you want to just get some more practice with sequences and series and make sure you understand everything. Thanks for watching.